For years, the North Sea off the coast of Germany has been the site of an intriguing mystery. Researchers have observed thousands, perhaps even millions, of divots on the ocean floor, ranging in size from small footprints to formations as deep as Lake Michigan and as wide as a football field. These strange pits are often found in clusters, and until recently, their origin baffled scientists. However, a new discovery might finally offer an explanation, potentially shedding light on one of the ocean's enduring mysteries: a historical connection to methane seepage. Before diving into the mystery of the North Sea pits, it's important to recall a similar occurrence from the late 1960s. Researchers studying the seafloor off the coast of Nova Scotia discovered pockmarks caused by methane gas. Our planet has vast underground pockets of methane, and when this gas pushes through the seafloor, it leaves behind scars by dispersing the surrounding sediment. While methane isn't the only substance that can create these formations, fluid venting is a common culprit, particularly in the deep ocean. Given this background, when scientists began finding divots in the North Sea, methane naturally became the first suspect. The North Sea is a hotspot for oil and gas exploration, so it seemed logical that hydrocarbons bubbling to the surface would cause these marks. But upon closer examination, the methane theory didn't hold up. The North Sea's unique mystery. One area of the North Sea, just west of the island of Sylt, provided particularly puzzling evidence. The pits in this region would mysteriously appear and then fill in again, leading researchers to speculate that storms were shifting sediment from the nearby island, covering the pits. They initially theorized that episodic methane bursts were responsible for the formations, with the storms acting as nature's broom. Yet when scientists modeled how much methane would be required to create these pits consistently, the numbers didn't add up. It would have taken an extraordinary amount, around 5 kilotons of methane per burst, to produce such frequent and widespread pits. That led to two possible explanations. Either there was far more methane under the North Sea than previously estimated, or something else entirely was at work. The search for answers continues. To resolve the debate, researchers from Kiel University embarked on a mission to map the ocean floor using echo sounding, a type of sonar used to detect gas bubbles and other abnormalities beneath the surface. After covering thousands of kilometers, they couldn't find any methane traces in the region. Even more perplexing, the shape of the pits didn't match what methane venting would create. Instead of the expected conical forms, the divots were flat circles, which pointed to an entirely different process, possibly related to marine life. Could porpoises be the culprit? The flat, circular pits led researchers to wonder if the phenomenon might be linked to foraging behavior by large marine animals. Specifically, porpoises were identified as a possible suspect. These marine mammals dig into the seafloor with their noses, searching for sand eels, their primary food source. The overlap of porpoise and sand eel habitats with the study area in the North Sea strengthened this theory. While scientists couldn't capture images of porpoises digging in the murky North Sea waters, the circumstantial evidence was compelling. This would mark the first time large marine animals, or megafauna, were observed influencing the seafloor on such a massive scale. Typically, bioturbation, the process by which animals disturb the seafloor, mixing oxygen and nutrients into the sediment, is associated with smaller creatures. If porpoises are responsible, it would change our understanding of how larger animals contribute to ocean floor ecosystems. Implications for seismology and marine science. If confirmed, this discovery would also have important implications for seismologists. Methane seeps are often viewed as potential indicators of tectonic activity, with their presence sometimes signaling an increased risk of earthquakes. Being able to differentiate between pits created by methane and those formed by marine life could improve our ability to monitor tectonic activity, helping researchers focus on areas where earthquake risks are more significant. This breakthrough showcases just how complex and interconnected marine ecosystems are. While porpoises might not have the same reputation as dolphins or whales, they could be playing a surprisingly large role in shaping their environment. Whether caused by methane or megafauna, the North Sea's pits remind us of the many mysteries that remain hidden beneath the ocean's surface. Marine life continues to amaze and intrigue us, fueling the curiosity of researchers and enthusiasts alike. As scientists delve deeper into the mysteries of the ocean, who knows what other secrets might come to light?